Hi, everybody. Now that we've already covered statistical significance sort of in broad terms, I'd like to introduce a new concept called effect size. By understanding effect size, it'll also help us to understand what statistical significance is because we can see how they are different from each other. But in fact, they are complementary to each other in many ways. So let's see how that works out. Once again, statistical significance allows us to now say with some confidence that there was an impact of the independent variable on our dependent variable, okay? Or there's some association between these two variables. There seems to be some kind of interaction among these variables or between these variables. So essentially what it's saying is it's an unusual statistic to have found. We wouldn't have expected to find a statistic this size unless there really is something going on between our variables or among our variables in cases where you have more than two. So in other words, we really probably didn't find this statistic by mistake. It certainly is possible, but unlikely. Okay, so we can sort of safely assume that there's something going on in our variables. Now that's important. That's a wonderful thing to find. It's very useful. However, there's more to it. And I think I'm going to demonstrate that pretty easily with a couple of examples here. So follow me through on these examples and I'll show you what's sort of missing from statistical significance by itself. So let's say that we've got some large, well-controlled study, a double-blind study, just a very brilliantly designed study. Everything looks great, fantastically designed, can't really critique too much on it. And they suggest that people who used a cell phone had significantly higher likelihood of developing brain cancer over the course of their lives compared to those who did not use a cell phone. Now, just to clarify, I am not aware of any such study, so this is just an entirely made-up scenario. Let's just go with that, though. So imagine that. So I think what your average person would do is say, I'd better get rid of my cell phone. I don't want brain cancer. That sounds terrible. And of course, that's maybe a natural gut reaction, especially somebody who doesn't quite understand what statistical significance is versus other things. So let's talk about what's going on. And I think the best way to do that is to show you the data that could lead to such a finding. Let's imagine these are their data. In other words, this is what they collected in this particular case. They had over 10,000, they had 10,080 people. And they found people who did not use a cell phone, 5,030 people who did not use a cell phone up here. I don't know where they found them, but they found them. And they found 5,000 people, 5,050 people who did use a cell phone. Then they tracked them and said who of these people had a brain cancer diagnosis over the course of their lifetimes. And this is what they found. So they run the statistics and they found this. This is a statistically significant finding. This is a chi-squared value. You don't need to worry about what that is because we haven't covered that in this yet. But the p-value is what's concerning here. The p-value says that the likelihood of having found a statistic this size is less than 2.6% unless there really is an effect going on here, unless there is some impact of one of these variables on the other. Okay, so that means this is statistically significant. That means we would not have expected to see this unless there's something going on. And so there's a high likelihood that there is an effect of cell phone use on brain cancer. Now, really quickly, which of these is the independent versus dependent variable is actually open a little bit to debate because of the design here. But granted, let's just take all of this with a grain of salt. So you might also look at the numbers and say, well, wait a second, but out of 10,080 people, only 80 people had brain cancer. That's almost nobody, right? And the differences between brain cancer in cell phone use versus not cell phone use is very similar. In fact, 0.6% if you didn't ever use the cell phone, you still had a chance of getting brain cancer. It's not that different from a chance of 1% when you do use a cell phone. So maybe it's fine if I use my cell phone. Maybe I have increased my risk, but it's ever so slight anyway. Maybe I'll go ahead and use a cell phone, right? So this is something else. This is something that statistical significance did not tell us about. If I say there was a statistically significant difference between the groups and you were more likely to get cancer with the cell phone, that's part of the story. That's an important part of the story, but it's not everything. So before we dive more into what effect size actually tells us, let me give you one more example to see if that helps. Let's imagine there's a weight loss pill. This weight loss pill is touted as being magical and helpful and useful. And so again, they have an excellent study design. They say it was a double-blind, completely randomized study, randomly selected, randomly assigned. 300 people, that's a pretty good sample size. That's not bad at all. And those who took the pill lost statistically significantly more weight than those who did not. And they give you all of their statistics. They say, again, right here, here's an independent samples t-test that we covered already. and the p-value is less than 5%. So in other words, the probability of having made a mistake here, and there really is no effect of the weight loss pill on the weight loss, is less than 5%. So therefore, it seems safe to say there's really something going on with this weight loss pill, right? In fact, they go even further and say these people lost twice the weight in as the placebo group in this course study over 6 months. So now a lot of people go, well, I'd be stupid not to, right? Shouldn't I go ahead and give them my credit card? Sign me up. Again, let's take a look at their data. Although this is statistically significant, if you take a very close look at their data, this is what we find. So in other words, we've got 150 people in the placebo group, 150 people in the diet pill group, okay? That's fine. The average weight lost in the placebo group was 3 pounds over 6 months, and the average weight lost in the diet pill group was 6 pounds over 6 months. So again, they were accurate. They said correctly that the people in the diet pill group lost twice as much weight on average as the people in the placebo group. However, what you'll also notice is both of them had standard deviations of 13. Now, a quick look at the math suggests that means that people in both groups, some people in both groups gained weight. In fact, a lot more people gained weight in the placebo group than in the diet pill group. However, does that seem worth it to you is sort of the question, right? If I'm looking at these numbers and I'm going, okay, I've got this diet pill possibility. It looks like if I don't use the diet pill, I have a chance of losing about 3 pounds over 6 months. If I do take the diet pill, I have a chance of losing 6 pounds over 6 months. And to me, my gut kind of says that doesn't seem worth it, especially if there's a possibility, a relatively strong possibility, that I could gain weight even with the diet pill. So maybe there are some more effective weight loss methods out there for me and my situation. All right. So I hope these two examples have sort of introduced the idea to is you're saying, well, wait a second. So statistical significance doesn't mean I should definitely buy into this difference. And that's exactly true, because what we're getting at is something we need called effect size. What statistical significance tells us is it's not likely that we made a mistake finding a difference here, but it doesn't tell us how big or how important is this difference that we did find in the two groups. That's something called effect size. As I hope you can see, that's very important to have effect size. It's very useful in addition to statistical significance. The sort of standard definition of effect size is something like it's an index of the magnitude of one variable's effect on the other. Or you could also think of it in a little bit more casual terms as it tells us how different the two groups were that we tested. If we have two groups, in some circumstances we might have 3 or 5 groups or whatever, but it tells us how big of an impact the independent variable had on the dependent variable. So again, let's contrast that with statistical significance. Statistical significance says, is there a difference between these groups? Did the variable seem to have an impact on the other variable? And then the effect size tells us how big of an impact did the independent variable have on the dependent variable, for example. Okay, there are statistical tests, lots of different kinds of statistical tests, and there are effect size measures for most of them, not all of them, but most of them do have effect size measures. And they're going to be different for most of these statistical tests, so just make sure that you're using the correct one for the correct test as you go on in the future. So one more analogy, and of course in future videos we'll calculate some of these measures of effect size. But a nice way to think about this helps me a lot anyway in thinking about effect size. Let's imagine that there's a meteorologist, and a meteorologist predicts that there's a 90% chance for rain on the next day. Let's say it's your wedding day, right? And they say 90% chance of rain for the next day, and that's devastating. You've got so much planned, and you're going, oh no, what do I do? So they tell you there's a high probability of rain, right? That's very useful for deciding what to do. Do you cancel? Do you delay? Do you need to just make sure there are umbrellas out for everybody? How bad is this going to be, right? It seems pretty certain there's going to be precipitation tomorrow. But what we don't know is how much rain to expect, for example. And that would be additionally useful. So let's imagine that the meteorologist says, it's going to rain tomorrow. There's a 90% chance of rain tomorrow, essentially. And I predict 4 inches of rain. That's a lot of rain, right? So if there's a lot of rain predicted, now not only do you know it's very likely to rain, but also it's very likely to rain a lot. So this is sort of analogous to the effect size versus statistical significance. So if I say there's a high probability of rain, that's analogous to the statistical significance. It would be expected that it actually rains tomorrow. It would be unusual if it does not rain tomorrow, given the information I have. But then I may want to know, is it a light drizzle? Is it going to be all day, although that's a slightly different question, or just is it going to be a flash storm just in a 10-minute window in the morning? And so as long as our wedding's in the afternoon or something, it's not a big deal. That is more like effect size. Effect size tells you just how big of a deal it's going to be. And that helps you get at something called practical significance. So some statisticians refer to it in this way, is that statistical significance is not practical significance, and practical significance is captured more in something like the effect size. It tells you how much rain there's going to be if there is going to be rain. So I hope that's a helpful analogy to think about this. Effect size down here and statistical significance up here. They're both important, they're both useful, but they get at different information. All right, a quick recap of what we covered today. Statistical significance looks at how likely is it that there is an interaction between these variables or among these variables. How likely is it that one of the variables is affecting the other? And then effect size tells us how big of a difference is one variable making on another variable? How big is that impact, for example? Both of these things are important to know. I would want to know both of these things for any given situation. Statistical significance is very useful, as is effect size, and I like how they go together very well. So if you're a researcher, it's important that you understand what measures of effect size to use and how to calculate them. And it's vital that you also report them in any kind of research to any kind of audience so that they're not making half-informed decisions, for example, or lightly informed decisions. You also need to, as a consumer of research, understand what these mean and seek them out in the research that you're consuming, whether you like it or not. Now, we will practice on calculating at least one of these in the next video, and I will see you then. Bye.